Since the beginning of time, humanity has asked plenty of difficult questions. For example, what is the meaning of life? Why are we here? But what I believe is the most important question out of the many few is, how do we square root negative numbers? I'm Ethan Hunt, and in this video, I'm going to show you how, with the use of imaginary numbers.
Throughout time, many people have attempted to answer this question and square root a negative number, especially when it is found in the quadratic formula. In this example, most historic mathematicians would have stopped at this step, as they could not go any further with their current set of knowledge. And this makes sense, since when we square root a number, we're essentially asking what number multiplied by itself would make the number under the root sign. However, with the real set of numbers, this is impossible in our case, as there's no number squared that will equal a negative number.
Nevertheless, mathematicians in the 17th century were frustrated with this problem and essentially said, screw this, and created a whole new system of numbers called imaginary numbers. Now, as complicated as this sounds, the idea behind it is actually fairly simple. Essentially, the square root of -1 is equal to I, where I represents an imaginary unit.
Now, we can look back at our attempt to use the quadratic formula earlier and see we can solve our unsolvable problem by applying our new piece of knowledge.
What is that I hear you asking? What does this answer mean? Well, first I can tell you, we can express this answer on a normal Cartesian plane.
Complex numbers, which are simply numbers that contain an imaginary part and or a real part, operate on a whole new dimension compared to a normal Cartesian plane. What we must do to this graph is add an imaginary dimension to create what is known as an Argon plane. In this plane of existence, the imaginary number is represented on the y-axis, and the real number is represented on the x-axis.
However, after knowing all this information, you might still ask, Ethan, this is cool and all, but how does this abstract concept apply to me in the real world?
Well, the imaginary unit I, along with other mathematical constants such as e, pi, 0, and 1, are used in Eulers Identity. Not only is this identity a prime example of something called mathematical beauty, but the concept behind the formula is also highly applicable. For example, Euler's identity is often used to simplify calculations in many scientific fields, including physics, when dealing with the phase transition of waves, and electrical engineering, when adding together the power of resistors and currents, will help to ensure a device gets a constant amount of power.
Heck, I mean, imaginary numbers are probably even used to create the circuits within the device you're watching this video on right now. It's truly crazy to think about how involved this imaginary unit is in our daily lives. That's all, folks. Thanks for watching.